Hello everyone, myself Harish Kennedy. I am the PMRF Fellow at IIT Roorkee Department of Hydro and Renewable Energy. Today I am going to discuss about the assignment 11 problems of the basic electrical circuits, the course instructor Professor Ankush Sharma. This assignment 11 mostly deals on the basics in the control systems, that is block diagram reduction techniques and state space modeling, that's state space modeling and signal flow graphs. Okay, first question. Uh, In the feedback scheme shown in the figure, the transfer function of the closed loop system will be, means we have to find out the transfer function of the closed loop. Means if you consider this complete unit as a one block, you have to find out the transfer function. Transfer function means it is simply output by input, right? But it is an S domain, C of S by R of S. C of S is this one, okay? What about that R of S? R of S at this point. It means here at this point, this R of S is coming, and from this also it is coming. Means the input to this particular block is C of S. So we can write C of S. The output of this point is, it is just a gain block. So we can simply multiply that thing. It is beta into C of S. Here it is a sum block. Yeah, this is a sum block. It adds the signal from this side and adds the signal from this side. It means it is the output of this sum block is simply addition of these two signals, that is R of S plus beta into C of S. So we can write R of S plus beta into C of S. Again, this block is a gain block. Whatever the applied to this gain block, the output will be simply multiplying the input with this much gain. So the output is same as C of S. We can write C of S as C of S equal to simply multiplication of the input signal and this gain block. The input signal is R of S plus beta C of S. The value of the gain block is A by 1 plus S tau. It is A by 1 plus S tau. So here from this expression we want to find out C of S by R of S. Here we have C of S, here we have R of S, and here one more C of S was there. We will send this C of S to this side. So both the C of S functions will be in one side. So we can simply calculate this transfer function by doing C of S by R of S. I am simplifying the expression. There is C of S equal to this R of S into, it's simply a this value into this gain function. It will gives A by 1 plus S tau into R of S. Now we are multiplying this function with this gain value. It will gives B, beta is a constant, so A by 1 plus ST into C of S. We can write like this. Now this C of S function, we can bring it to this. Actually it is sorry, here it is negative, right? Why? Because here the symbol will be is negative, so here it will be negative. So here it is negative r of s minus beta of c beta. So the same will be repeat here, r of s minus of beta into c of s here also. So we can bring write c of s terms one side, then it will be c of s. This side it will be minus, it is minus. So if you send to this side, it will be plus, right? So we can write plus beta a by 1 plus s tau into c of s equal to a by 1 plus s tau into r of s. One can common this c of s. So this will be, we can take c of s as common. Then here it will be 1. Why? Because only c of s term was there. You can make it into common. So it will be 1 plus beta a by 1 plus s tau. This function will be remain same. It is a by 1 plus s tau into r of s. Okay. We have a function in terms of c of s. We have a function in terms of r of s. What we need? We need c of s by r of s. So we will bring this r of s to this side. So it will be c of s by r of s. We are taking this function into this side. It will be this function by this function by this function will come. So we can rewrite this thing, that is c of s by r of s equal to this function will be our numerator. Our numerator will be a by 1 plus s tau by our denominator function will be this, right? It will be comes this side, so it will comes under denominator function. So our denominator function will be 1 plus beta a beta or beta a by 1 plus s tau. Okay, we can simplify this expression. R of s equal to a by 1 plus s tau by, you can, this 1 plus s t is the numerator term, so it is a LCM for both the things, so you can multiply this thing. So it will be 1 plus s tau plus a beta by 1 plus s tau, right? So we are going to cancel this one. 1 plus s tau and 1 plus s tau will be cancelled. So the c of s by r of s a by 1 plus st plus a beta. So the output function by input function, it is a transfer function. The transfer function equal to a by 1 plus s tau plus a beta. That is 1 a by 1 plus a beta plus s tau. The generalized formula for this thing is, here it is a negative feedback. So the generalized formula to obtain the gain, to obtain the closed loop transfer function of negative feedback is, it is the generalized formula we can write. Let us suppose it is a forward path gain it is our input, let R of S, our output C of S. You have a feedback path gain of H. Okay. Now you want C of S by R of S. If here it is negative, then this is the negative feedback system. The closed loop gain will be the G by 1 plus GH. If it is a positive, then it will be a positive feedback system. The gain will be, the closed loop gain will, sorry, it is C of S by R of S will be G by 1 minus GH. Okay, these are the generalized formulas to calculate the closed loop gain of a feedback system. One can calculate the, yes, yeah. One can calculate the closed loop transfer function by directly using these formulas also. Uh, Here instead of G, we are having A by 1 plus S. Instead of H, we are having beta. Here it is negative, so it is a negative feedback system. You can directly put those G and H values in this negative feedback system. So you can attain the transfer function by G by 1 plus GH. Coming to the next question, which among the following plays a crucial role in determining the state of the dynamic system? Usually, a system, there are the input variables, and there are the output variables, and there are the state variables. We can represent this system in terms of state vectors and state matrix form, that is x dot equal to matrix A into matrix X plus B matrix B into matrix U. Similarly, output function, output matrix Y equal to matrix C into X plus matrix D into U, where X is the state vector, and A is the state matrix, B is the input matrix, and C is the output matrix, and D is the feed forward matrix. Among all these things, the dynamic variable that is determining the state of the dynamic system, crucial, yeah, which among the following plays a crucial role in determining the state of the dynamic system is the state variables, that is state vector matrix, it is x dot. This state variables option A. Usually, when your circuit is having L and C elements, let us suppose your circuit is having L and C elements, the current flowing through the inductor is a state variable, and the voltage across the capacitor is the state variable. These are the state variables in in the AC network. So this will plays a crucial role in the dynamics of the system. That is, state variables plays a crucial role in the dynamics of the system. The third question is a feedback control system with a high gain K. A gain of the system is having the gain K. The closed loop transfer function is inversely proportional to. It means we have to find out the closed loop transfer function, and we have to find out the relation between the transfer function and these three terms. Which of the term is inverse having the inverse relation with the closed loop transfer function? So here these two blocks are connected in series. So we can multiply these two blocks, right? So this will be the gain, the total gain equal to K into G of S. The output is C of S. And the input is from some block. R of S. The feedback gain is H of S. Here it is positive and negatives. It means here it is negative means the this is a negative feedback loop. Negative feedback means just we calculated the form. We mentioned the generalized formula. If it is a negative means the closed loop gain is G by 1 plus GH, where G is the gain of the forward path, H is the gain of the loop. In our case, now forward path gain is K by K into GS. So the closed loop gain, closed loop transfer function C of S by R of S equal to forward path gain, that is K into G of S by 1 plus forward path gain, that is K into G of S into H of S, right? H of S means the feedback gain. So the closed loop transfer function C of S by R of S equal to K into G of S by 1 plus K into G of S into H of S. This is our closed loop transfer function. The question is, the closed loop transfer function is inversely proportional to K, G, H or Kg. Which of the following terms, like if you consider K, the K is in the numerator and the denominator. It means we cannot directly define say the K is a proportional or a inversely proportional. Similarly, G of S equal is also in the same position. And if you consider H of S term is in only in the denominator. So we can write C of S by R of S 1 by H of S. It means why? Because only the H of S term is only in the denominator. So we can write C of S is directly inversely proportional to H of S. That is, which of the following term is inversely proportional means, sorry, the H of S term is inversely proportional to the closed loop transfer function. It means the feedback gain is inversely proportional to the closed loop transfer function. It means the gain of the feedback path will most affect on the closed loop transfer function. Coming to the fourth question is the block diagram of the control system is shown in figure with the transfer function of g of s equal to y of s by u of s. Y of s means here it is in time domain, so we can write y of t y of s. U of s means here we are having the input in u of t means you can write u of s. It means here the block diagram is given in the time domain. Okay, we want to find out the transfer function. This transfer function is the ratio of y of s by u of s. It means the output in s domain by output, sorry, input in s domain. We can write transfer function equal to simply Laplace transformation of y of t by u of t. Okay. In other words, we can convert each blocks into S domain. Okay. Integrator means what is the equivalent in the S domain? Simply it is 1 by S. Okay. We can write the integrated terms as a 1 by S. So give me a second here. Now all the integrated terms is 1 by S, 1 by S. Here it is u of s, here it is y of s. First we will consider this loop up to this point. It means here it is forward path, here it is feedback. Here it is negative means it is a negative feedback loop. So yeah, I will put the same figure. Give me a second. Okay, now we are considered up to this point. It means integrator means 1 by s. So what is the closed loop transfer function of this thing? It is a negative feedback system. So it is simply g by 1 plus gh, right? It is a negative feedback system. But in the place of g, we have 1 by s. In place of h, we have 3. So what is the closed loop transfer function? It is the closed loop transfer function is g by 1 plus gh. The g is 1 by s, 1 plus gh, 1 plus g is 1 by s into h is 3, right? Yeah. So you can simplify this thing. It is 1 by s plus s plus 3 by s. I can write like this. I'm making this s as a LCM. So here it will come s and here it is 3. So we can cancel this s and this s. it will be 1 by s plus 3. This is the equivalent gain of this particular loop. Similarly, the same thing we can apply here also, right? Here, the gain g, forward path gain is remains same, it is 1 by s, whereas the feedback path gain, that is h equal to 12. Means in earlier case, g equal to 1 by s, h equal to 3. This is for first loop. Now the second loop, the g equal to remains same, that is integrated only 1 by s, h equal to 12. Here it is negative sign or positive sign? Here it is again, it is a negative sign, means it is again a negative feedback loop. Negative feedback loop means the closed loop transfer function is remains same, that is g by 1 plus gh. In place of g, we are writing as a 1 by s into 1 plus, in place of g we are writing 1 by s into h, in place of h we are writing 12. Okay, it will be 1 by s. We are taking s as an LCM. We can write s plus 12. This s and this s will be cancelled. So the equivalent will be 1 by s plus 12. It means instead of this whole loop, we simplified this one. The transfer function of this whole complete block is 1 by s plus 3. 1 by s plus 3. Okay. The next loop, I will add one more figure. The next loop means only this portion. The next loop is this one. The transfer function of this loop is 1 by s plus 12, right? So our complete block diagram is this one. First, we simplified this portion represented in a one gain block, and we simplified this block represented in a one gain block. Okay, I'm redrawing the same. This input, this is some block. This input is R of S or yeah, U of S. Okay, we simplified this one, this transfer function. Yeah, this block represents the closed loop transfer function. This block represents the closed loop transfer function of this whole portion. The whole portion closed loop transfer function is 1 by s plus 3. So instead of that whole loop, I am writing the closed loop transfer function of that particular block loop 1 by s plus 3. Okay. After this loop, after this loop, it is connected to gain block of having gain 2. It means the next is gain 2. after 2, after this gain block 2, there is a forward path and a feedback path, that is negative feedback path. It means one can consider this portion, it is a forward path which is having an integrator, and a feedback path, it is a 12. We already calculated the closed loop transfer function of this particular closed loop, that is 1 by s plus 12. So instead of drawing this particular loop, I am writing the closed loop transfer function, that is 1 by s plus 12. So we reached up to this point. So from this point to input side, there is one feedback path which is having a gain of 9, that is feedback gain 9, and here it is a negative sign, it is negative feedback path. So here it is a negative sign, this is a feedback, and the gain of this particular feedback is 9. Okay, here these three gain blocks are connected in series. So the equivalent gain is product of these three gain blocks, right? It means 1 by s plus 3 into 2 into 1 by s plus 12, that equal to 2 by s plus 3 into s plus 12, right? So we can redraw this thing. Instead of these three blocks, now we are representing with one block which is having an equivalent gain. The equivalent gain is, just we calculated, it is 2 by s plus 3 into s plus 12, that is 2 by s plus 3 into s plus 12. Again this is a negative feedback loop. Why? Because here it is a forward path is having a negative feedback path. So the gain of the forward path is, the gain of the forward path is 2 by s plus 3 into s plus 12. What about the feedback path? Feedback path is having a gain of 9. It means the value of h equal to 9. It is a negative feedback path, negative loop. So what is the closed loop transfer function? The closed loop transfer function of negative loop is, that is C of S, only, right? Yeah, Y of S. Y of S by U of S equal to Y of S by U of S equal to, it is a negative feedback, so it is G by 1 plus GH. But in place of G, we have 2 by S plus 3 into S plus 12. 2 by, sorry, 2 by S plus 3 into S plus 12 by 1 plus, in place of G, we have 2 by S plus 3 into S plus 12 In place of h, we have 9. Okay, we are going to simplify this thing. This fraction is same. The numerator will be same. The denominator we can write, we can take this as an LCM. Okay. Now the LCM is s plus 3 into s plus 12. So here it is, the denominator is 1, so it is simply multiplication. It is s plus 3 into s plus 12. Here the denominator is same as the LCM. It is simply 2 into 9, that is 2 into 9 is 18. This denominator and this denominator will be cancelled, both are same. So the equivalent will be 2 by s plus 3 into s plus 12 into, sorry, plus 18. This is a closed loop transfer function, that is v of s by u of s. However, in the options, he didn't given the directly a equivalent value, so we have to further simplify the fraction. Is 2 by, what is the value of s plus 3 into s plus 12? It is s square plus 3s plus 12s, it is 15s, plus 3 12, it is 36, plus 18, it is y of s by u of s equal to, value will be 2 by s square. 36 plus 18 means it is 54. So the value will be s square plus 15s plus 54. It will be, we can write s square plus 15s plus 15 in terms of s square plus 9s plus 6s plus 54. So 2 by, you can take common s in this 2, that is s plus 9. You can take common plus 6, that is s plus 9. It will be 2 by s plus 6 into s plus 9. Okay, you can take common this 6 and this 9. The fraction will be 2 by 6. You can take common, it will be s by 6 plus 1. You can take 9 from this thing, it is s by 9 plus 1 to 6 into 9, that equal to 2, 2 1 ja, 2 3 ja, it will be 1 by 3 9 ja 27 into s by 6 plus 1 into s by 9 plus 1. Okay, 1 by 27 into s by 6 plus 1 plus s by 9 plus 1. The option will be the option A. It is 1 by 27 into 1 by 1 plus s by 6 into 1 plus s by 9. The answer is 1. Right. This is how it means. In here we have a block diagram. A block diagram is having one loop, and this is having a one feedback path, and this is having a one feedback path. We have to choose which feedback path we are going to simplify, so the block diagram will be reduced. If you simplify this whole feedback path, so it we can represent with one closed loop. gain block. Similarly, if you simplify this feedback path, you can represent in one closed loop transfer function. So this closed loop transfer function, so this feedback path will be eliminated and this feedback path will be eliminated. Now you are having only this feedback path. So these three gains are in series. So you can simply multiply these three gains. It will gives one complete gain block with this feedback path. Again, it is a negative feedback system. You can simplify by g into g by 1 plus gh. Means if if a problem is having multiple number of feedback paths, you have to choose the feedback path which is going to reduce your blocks further. If you go directly to reduce this block, it is not possible. Why? Because here there is a one loop and here there is a one feedback path. So you cannot reduce directly the first this feedback path. That's why we are choosing to reduce this feedback path and this feedback path. Then this feed the whole gain of the system is a one closed loop and whole gain of the system will come as a other gain like this. It is three gains. So there is a no feedback paths in between. So we can simply multiply these gains. We multiplied the gains and now we have one forward path gain and one feedback path gain that is of negative sign. So we can simply, it is a negative feedback path. Negative feedback path we can write g by 1 plus gh. By simplifying this thing, we will get a closed loop transfer function which is 2 by s square plus 15s plus 54. You can further simplify. This is the equivalent option. That is option A. Mean if you want to reduce any block diagram, you have to choose the loop which is going to reduce your transfer function first. That is about the fourth one. Finally, the fifth one is signal flow graph is used to find. Means the signal flow graph is almost similar to the block diagram. We are going to represent the block diagram in terms of the signal flow graph. The option is it is used to find the transfer function of the system. That is, yeah, we can take one problem. Let us suppose you are having this the same block diagram in the previous. It is having the same block diagram. First, we will write nodes. Let us suppose this is our node 1 and this is our node 2 and this is our node 3 and this is our node 4. Okay, this is our node 5, this is 6, this is 7, 8, 9, 10, 11, 12, 13. Okay, one more, 14. How to draw a signal flow graph from a block diagram? First, we have to represent with some numbers. So, here we will draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we can represent 1, 2, 3, What is our input? Input is simply a u of s. What is our output? It is a y of s. So we are at this point, it is 1. Okay, a loop which is connected in between 14 and node 2. Okay, we are connecting a loop point from 14 to node 2. Like this direction, right? It is 14 to node 2, but it is having a negative sign. It is a negative feedback. So the gain of this path is this minus 9. Why? Because it is simply a gain of the feedback path into a sign. Next, the 3 point is connected to a sixth one. What is the gain of this path? This path gain is 3. So I am writing 3. What about the sign? Here the sign is negative. So here we need to write minus 3. Next, here it is. Point node 4 is here and node 5 is here. In between node 4 and 5, there is a integrator block. Means in between node 4 and 5, there is a integrator block. The gain of the integrator block is, it is 1 by s, right? From point 5 to 6, it means in between these things. From point 5 to 6, there is no any gain, so it is simply a gain of 1. This is also 3 to 4, there is no gain, it is 1. Next, we reached up to the point 6. Okay, 6 to 7, it means in between these two, there is no gain is there, so we can write in between 6 to 7, we can write 1. What about 7 to 8? 7 is here and 8 is here. In between, there is a gain of value 2. Okay, so 7 to 8, there is a gain having value 2, right? Then 8 and 9, 8 and 9, 9 point is here and 8 point is here. In between, there is no any gain block, so we can write the value of gain is 1. Okay, then this is as a 10, this 10 and this is 13. So from 13 to 10, there is a one path which is having a gain of 12. Means we are drawing from 13 to 10, right? It is 13 to 10, 13 to 10, which is having a gain 12. What about the sign? Sign is here is negative. So here the sign will be a negative sign. This integrator, this integrator is connected in between 11th node and 12th node. So the gain in between the 11th to 12th is 1 by s. Okay. Then this is a 12th node and this is a 13th node. In between there is no gain blocks. We can write it is having a unity gain. So we can represent it with 1, and this is 1, this is 1. Okay, this is how one can draw the signal flow graph from the block diagram. Okay, the gain of the signal flow graph is, sorry, gain mean the transfer functions from the signal flow graph is y of s by u of s equal to 1 by delta